Museums Victoria respectfully acknowledges the traditional owners of the lands where we work, the Wurundjeri and Boonwurrung peoples of the Eastern Kulin Nation, and First Peoples language groups and communities across Victoria and Australia. We pay our respects to their elders past, present, and their emerging leaders. Our organisation, in partnership with the First Peoples of Victoria, is working to place First Peoples living cultures and histories at the core of our practice.
Good evening, everybody. Welcome. Welcome to Melbourne Museum. Wonderful to see you here in person, and know that there are many of you there online as well. Welcome. Very happy to have you all here. My name is Narine Weiss, and I'm the Director of Research and Collections here at Museums Victoria. It's a great pleasure to welcome you this evening to this very special event. I also would like to begin by acknowledging the traditional owners of the land Museums Victoria operates from, the Boonwurrung and Woiwurrung people of the Eastern Kulin Nations. Pay my respects to their elders, those that have passed, that are now here, present, and also those that are emerging, to all the elders and First Nations peoples who are here with us this evening. Welcome. I also would like to acknowledge our media partners, Saturday Paper and 7am Podcast, who have supported this event. Also, we have Cindy and Mac are providing some Auslan interpretation for tonight's program. Thank you so much, guys. Lovely to have you here. Tonight's event, it's part of our Future Forum's Ideas Shaping a Tomorrow series, and they are monthly conversations that are presented by Museums Victoria. I think it goes without saying that we are at a rather critical time in our history. We're living in an age of continual technological discovery and incredible, remarkable change. Humanity is facing an expanding number of complex challenges. With rapid advancements in scientific research and groundbreaking discoveries, not only are they transforming the way that we live, they transform how we experience the world and how we are relating to each other. In this series, Museums Victoria will be inviting luminary thought leaders from Australia and overseas to reflect on the big ideas and important questions that are shaping our future. So tonight, as part of that series, we are unlocking the deep past. This has, of course, been inspired for us here at Museums Victoria by our new exhibition, which has just opened, Triceratops, The Fate of the Dinosaurs. Dinosaurs were an astonishingly resilient species. They roamed the earth for almost 165 million years, with more than 18,000 of that species having descendants that are around us today. We can learn about how these creatures lived and adapted to their environment by studying their fossils. And of course, we're very much focused here at Museums Victoria on our very own Horridus. Our newly acquired specimen, a 67 million year old fossil. It is the world's most complete and finely preserved Triceratops, and it is here as part of the museum collection for us to see now and for your offspring in the future and their grandchildren in the future. That is now a part of our history here in Melbourne. Beyond dinosaurs, we can also witness the interactions over millions of years between humans, animals, plants, and the land through studying our geographical landscape. This research and the discoveries uncovered provide crucial information about humanity's present, but particularly with us looking into the future. And tonight we are going to hear from world-leading experts about how we can use this knowledge to transform our way of life, to solve complex environmental challenges, and to ensure a thriving future for all of us as humans and for all the other species that are on our planet now. We'll take audience questions this evening. so be prepared. We can use the online Q&A platform Slido, so please no shyness or coyness. Join the conversation. We're here to answer your questions. And you can also vote on other questions by liking them. So you've got some information there on the screen. Please don't hold back. Now, to submit a question, simply scan that QR code or go to the slido.com using your mobile phone or other device and enter the event code deep past, and it's there on the screen, deep past 2604. So if you're watching online, you can simply scroll down on the web page until you see the Slido box where you can type your question directly into that space. Now, I'm delighted to introduce to you our host for tonight. Our host is Tanya Ha. Tanya, waving over there on the other side of the stage from me. Let me tell you a little bit about Tanya. Tanya is an award-winning Australian science communicator and journalist. She's an environmental advocate. She's a best-selling author. She's a renowned media commentator on science and environmental issues. Tanya is currently the Director of Engagement at Science in Public and a board member of Diversity Council Australia and Western Portwater. She serves on the advisory boards of the ARC Centre of Excellence in Excite on Science, the Marine Energy Research Centre, and the very exciting Leonardo Group of the Science Gallery Melbourne. Tanya is a past Vice President of Science and Technology Australia and a past board member of Sustainability Victoria and Keep Australia Beautiful. Now, some of you may be familiar with Tanya through her work as an on-air reporter for the marvellous ABC TV show Catalyst, and perhaps also from her time as the Eco Coach in the landmark SBS show Eco House Challenge. Who didn't see that? I hope you didn't miss it. Tanya's books include Greeneology and Green Stuff for Kids. In 2010, she won a UN Association of Australian Media Award for environmental reporting. So I think with all those credentials, you can understand that it gives me great pleasure to hand over to Tanya now to introduce our guest speakers this evening, and let's begin the conversation. Thank you so much.
Thank you, and welcome again to both our online audience and our in-person audience here on the lands of the Kulin people. I always think, as someone with an environmental and a science background, that it is so important and meaningful to acknowledge the first Australians because they have lived sustainably in this quite harsh environment, this country, for 60-odd thousand years. And they are our first scientists, our first engineers. The Budge Bim irrigation and eel farming system is still in operation in southwestern Victoria. And it's also, here at the museum, if you do visit another day when it's opening hours, or for the online audience, if you want to come and visit someday when you've got the time, then you'll see the Forest Gallery. And I know for me, when I first looked at the Kulin seasons in the Forest Gallery, Melbourne weather made sense. So if anyone teases you about Melbourne weather, if you live in Melbourne, then tell them that if they understood the weather in Melbourne the way the first Australians, the Indigenous people, the Kulin people of this region understood it, then it would make sense to you too. Now, one little housekeeping thing. If you do have a mobile phone on you, I'd ask you to switch it to silent, but I won't tell you to turn it off because they're handy little things. You can tweet or post on Facebook, at least as long as Elon Musk lets us. But if you do want to join the conversation online or share the things that inspire you or that you're learning tonight, then do use the hashtag FutureForums. You can also add in the handle Melbourne Museum because that's who's bringing the event to you. And again, a reminder that you can ask your own questions because tonight really is about giving you, the audience, the opportunity to pick 3 marvellous brains. So you can do that by going to slido.com. The event code is DEEPPAST2604. And please do send in your questions. Otherwise, I'll have to ask all the questions and, I don't want to hear the sound of my own voice. I want to hear your questions too, although I will have plenty of questions for our panellists. And it gives me great pleasure to introduce them. Now, to start off, on one of our screens, I'd like to introduce Professor Steve Bressati. Now, you'll hear a transatlantic accent in a moment, but don't let that confuse you because he's joining us live from the United Kingdom. So good morning, Steve. He is a paleontologist from the University of Edinburgh. He's widely recognised as one of the leading paleontologists of his generation. He has over 150 peer-reviewed scientific papers during just 15 years of research in the field, and he's named and described dozens of new species of dinosaurs and mammals. And he has also done groundbreaking studies on dinosaurs and how they rose to dominance, how they went extinct, how mammals replaced them afterwards. And these research interests look at that evolutionary transition from dinosaurs and birds to the rise of carnivorous dinosaurs like the Tyrannosaurus rex and the Velociraptor. Did I say that correctly? It's one of those ones that I always trip over. In other words, he studies the fierce carnivorous meat-eating ones. His 2018 book, The Rise and Fall of the Dinosaurs, was a New York Times bestseller. It's also available in the Melbourne Museum bookshop. So if you're coming back for that visit and to look at the Forest Gallery, do pick up a copy of his book as well. He's the science consultant for Jurassic World 3, the movie, and he has a forthcoming book, The Rise and Reign of Mammals. So welcome, Steve. Just to kick things off, I wanted to ask you, and I'll also be asking your fellow panellists later, what makes you tick? What do you research and why?
Well, good evening, everybody. It's good morning for us here in the UK for Susie and me. But thank you for the very kind, kind of outrageous introduction. It sounds a lot like the boilerplate thing my publisher sends around the intro. So, hey, I appreciate the kind words there. And I'm very excited just to have this conversation. I'm one of those lucky people, Susie being the same, that gets to dig up dinosaurs for my job, which is really just a remarkable thing. I became really enthused, obsessed about dinosaurs and other fossils when I was a teenager. I made a career out of this and get to do fun things like travel around, work with amazing people all over the world, finding new fossils and using these fossils to understand how groups like dinosaurs and mammals, how they originated, how they diversified, how they interacted with their world. And for scientists like us, ultimately, many of us want to understand evolution. We want to understand how evolution works over very, very long time scales, and how real plants and animals and ecosystems respond to real instances of climate and environmental change in the past. Our world today is changing very, very, very fast. And we are mostly to blame for that. But the kind of changes that are happening, rising temperatures, rising sea levels, these kind of things, they have all happened before with different causes, but they've happened before, and we can look in the fossil record, the geological record, to understand what has happened to plants and animals when these kind of changes have occurred. So fossils are the clues there, and dinosaurs, although dinosaurs like your new Triceratops, everybody loves these dinosaurs, they're very popular, kids love them, they're great exhibits. But more than that, they are the clues from Earth history that we can really learn from.
Excellent. We'll be asking you more questions about what we can learn from them later. And it's interesting when you talk about the changes we're facing environmentally. I might mention to the audience the significance of what I'm wearing tonight. That's the global average temperature record. So from shades of cooler blue through to warmer red, that is the recorded global average temperature and how it is certainly warming and warming rapidly. Thank you, Steve. I'll now introduce our second panellist, Dr. Susanna, although she's happy for us to call her Susie, Dr. Susie Maidment. She's coming to us via video link also from the UK. She's a researcher and curator of fossil archosaurs at the Natural History of Museum in London. And her work focuses on the paleobiology of bird-hipped dinosaurs. I was thinking I'd love to watch how bird-hipped dinosaurs is signed. Okay. I was hoping for, a nice little wiggle hip, but I'm being cheeky now. I'm making Cindy's job difficult. Sorry, Cindy. Back to you, Susie. Now, we were just saying when I went off on a tangent on bird-hipped dinosaurs, she also researches bias in the fossil record and the geological context of dinosaur evolution. Susie has a PhD in vertebrate paleontology from the University of Cambridge. And prior to working at the National History Museum, she was a research fellow at Imperial College and a postdoctoral researcher at the Natural History Museum. And in addition to these roles, she spent 2 years working in industry as an exploration geologist. Now, if you tune into radio through the internet, you can also hear her as a regular guest on BBC Radio 4's The Life Scientific and the fabulous The Infinite Monkey Cage show as well. She was one of National Geographic's UK's Women of Impact in 2019. And in 2016, she was awarded the Geological Society of London's Lyell Fund and the Paleontological Association's Hodson Award, both for notable contributions to paleontology. Susie, tell us, what do you love about your work and why do you do it?
Yeah, well, hi everybody. Good evening. It's morning here, as Steve said, but good evening to you. Thanks for that lovely introduction, Tanya. So I should probably clarify when I said, when you said bird-hipped dinosaurs, these are mostly herbivores. These are things like Triceratops and Stegosaurus and Iguanodon and all those dinosaurs that don't have kind of big pointy teeth that are flashy and in the media, but I think are really super interesting. What I really love, Steve has said it very well already, but what I really love about doing my job is I really love that excitement of finding something and seeing something that literally nobody has ever seen before. It's an extremely exciting thing to be able to do. But really, I think the reason that I do it is, despite a childhood fascination with dinosaurs, really at heart I'm a geologist. I'm interested in rocks and what the rocks can tell us about past. What makes it interesting, what makes the dinosaurs interesting, is this context for me. What the dinosaurs can tell us and what fossils in general can tell us about past ecosystems and ecosystem change.
I guess that's part of the rocks tell the setting of the story of the dinosaurs, not just the dinosaurs themselves. Is that right?
Yeah, absolutely. It's actually one of the reasons why it's really important, if we can, to dig up our own specimens. We can't always do that. We at the Natural History Museum often acquire specimens for our collection by purchasing them or through donations by amateurs who have dug them up, and they have a huge role to play in our community. But sometimes that means that we miss a little bit of that contextual data. How was the specimen lying in the ground? What does that tell us about how it died? What were the exact environment that the rocks were that it died in? We miss a lot of context if we're not able to understand the rocks themselves. So paleontology is an incredibly multidisciplinary subject, really. We have people who have backgrounds as geologists, like myself. We have people who come from a much more biological or zoological background. We have people who come from engineering and sort of biomechanicists. A huge diversity of skills and knowledge that we need to bring together to be able to understand these ecosystems and these animals. Mm-hmm.
Yes, that makes sense. It now gives me pleasure to introduce the third panellist who's been sitting here, politely and quietly on stage. Associate Professor Michael Sean Fletcher. He's in person with us today at the Melbourne Museum. He's Director of Research Capability at the Indigenous Knowledge Institute and Associate Dean of Indigenous Research at the University of Melbourne. Now, he's interested in the long-term human-environment interactions, and Michael is also a descendant of the Wiradjuri people. His research group focuses on understanding how landscapes evolve through time using microfossils stored in sediments. Michael's recent research has had a particular emphasis on how Indigenous burning has shaped the Australian landscape and how Indigenous knowledge needs to be meaningfully incorporated into landscape management to tackle many of the environmental challenges we're facing today. Please make him welcome, and please make our other panellists welcome. I haven't given you a chance to clap everyone yet, but Michael, what gives you hope and passion in your work? You know, why do you get out of bed and come to work each morning?
Yeah, it's a good question. Thanks for hi everyone on the stage, and you guys from England and everyone online. I'd like to make a plug for the little guy here. I work with fossil pollen, which you need a microscope to see, so I'm waiting for there to be a giant exhibit of a pollen grain here instead of maybe a triceratops, or along with, you know. Maybe not as immediately glamorous, but as we were talking before, if the dinosaurs are the stars in the sky, all that black fabric around is the kind of stuff that I do. I fill in the context, the environmental change that happens through time, looking at these microfossils and understand how environments change and drive ecosystem dynamics. What drives me? A lot of things. I just love the world, and I love trying to understand nature. I love getting out on country and trying to understand and read country. And I always think of a John Lennon, a bit of a Beatles tragic, and I think of a John Lennon quote, a lyric from one of his songs, which is, "How can we go forward when we don't know which way we're facing?" And landscapes are the product of historical contingencies of the past, and they're all geographically distinct. Australia, for example, is a product of millions and millions of years of change and dynamics, and tens of thousands of years of human occupancy and management. And the landscape that we live in today is a product of all of that. And if we don't understand it, we can't manage it moving forward. So by looking into the past, reading that book, we're essentially developing a safe operating manual or procedure, getting a bit of the OH&S sort of paradigm that's been forced on me recently. But if we can't read that book, or we can't understand where we are or how to manage the landscape, then we can't move forward. And I think a classic example of this, and something that's really driving me recently, and it's great that you're wearing that top, is that society's fixated on the notion that the catastrophic fires that are really tearing Australia apart at the moment are a climate problem. But the work that we've done shows that it's actually a human management problem, that they began prior to climate change. And it's a landscape change thing that's being exacerbated by climate. So without knowing that, we applied incorrect management paradigms to solve our problems. So by looking into the past, we can sort of understand how to do things appropriately.
That's a good point. And I think, like, don't downplay the pollen research. Are there any people who get hay fever or asthma in the room? I think understanding the evolution of pollen is probably critically important to some of those people. We've got some questions coming through from the audience, and I will encourage you, if you do have a question that is for a specific panellist, then you can specify, a question for Michael or Susie or Steve. But I'm guessing that this first question here from Claire probably lands either in Steve or Susie's area. What do you think of the findings from Robert De Palma presented in Dinosaurs, The Final Day, the new documentary narrated by David Attenborough? Susie, do you want to start off with that?
Yeah, sure. I think that the site looks incredibly exciting. The way it was presented in the documentary makes it very compelling. I think that the work that they've published so far is very interesting. For example, the spherules, which are these droplets that rain down after the impact. So everything was vaporised, and then these droplets rain down. And they've actually found the spherules in the fish gills. And I think that's really compelling that the time correlation between these events. What I would really like to see is for them to publish more of their work. So a lot of that stuff that they're presenting hasn't been published, it hasn't been peer reviewed. And at this point, it's very difficult to comment on that. I enjoyed the programme very much. I thought it was very good. I think that it's really important when we are portraying how paleontologists work. One of the really great things about paleontology, particularly about dinosaurs, is that they are a gateway for children into understanding science, understanding evolution and the natural world. And we can talk about evolution in terms of dinosaurs because children understand it and will be engaged with it. And then we can take them on journeys to understand things about environmental change and evolution and all this stuff. So it's really critically important that we represent paleontologists in a helpful way, I think. And that means including a diversity of people and not representing paleontologists as cowboys who work in the Badlands with their cowboy hats on. Sometimes we do that, but we don't, and we're not all men, and we're not all white guys with beards. And I think that the documentary, in addition to its findings, could actually have done a better job at representing the diversity that we see among paleontologists. And I think that would have been more helpful for our audiences to understand who we are as paleontologists as well.
True, particularly given that we've got people with a memory of seeing Raiders of the Lost Ark to overcome as well, doesn't it?
Right, exactly.
Steve, what are your thoughts on the documentary?
Well, Susie handled the question very well, and thank you for that, Susie, because it's a tough one. I'll just say a couple of quick things about it. I completely agree with what Susie says about the site. It's very exciting, some big, bold claims. Some of those have been published and peer-reviewed. These impact spirals in the gills of the fish. 2 different teams have studied those using a lot of different techniques. They've published them in leading journals. That is very credible. Those fish, to me, are tied to the impact. They were killed, soon after the impact. There's dinosaurs, pterosaurs, mammals, many other things from the site that the documentary presents as being victims of the impact. It's possible, but it all comes down to the nuance, which is a very difficult thing of dating these packages of rock in a river system and tying them to the specific impact. That hasn't been peer-reviewed yet, so we're all awaiting that. And so I have a completely open mind there, and I hope to see those papers soon. The documentary is something that I consulted on. I was one of a team of consultants that was working behind the scenes to try to make sure that the science was rigorous. I find myself doing a lot of that these days, whether for film franchises or television shows. I think it was a very nice piece of television. What Susie says, I completely agree with. It's something that we talk about a lot in the development stage. There is another version of the documentary that will air in the US on Nova, and I don't know how international it will be, but that would be expanded. It'll be about twice the length, and it will have a much more diverse set of paleontologists. There's at least 10 people. It's not just paleontologists, but geologists and planetary scientists and others that are also involved with that one on screen. So it's a little bit less, David Attenborough, a little bit more wider cast of characters. I think that airs next month, so I hope that is viewable internationally. I think that will provide a much more realistic, accurate portrayal of modern-day paleontology.
That's actually a nice segue to a question that was posted by Anonymous. Anonymous has asked quite a few questions actually on my Slido list. But that talk of the different disciplines being involved in that film, the question from Anonymous is, there's a lot of flashy talk about interdisciplinary study. Do you ever work with people from the humanities? And I might actually take that to you, Michael, because I think that my guess is that your research probably is, your work probably is quite transdisciplinary. Can you tell us a bit about that? And I think, flashy term, I'm not sure how I feel about that.
It's a term that's used a lot, and sometimes inappropriately, sometimes appropriately. Yeah, I mean, I work in a geography department, which is by definition interdisciplinary.
Yes,
yeah, and I work
humanities.
I work across the humanities and the physical sciences. So it's a regular thing. And I think it's an important thing that we need to do, especially when dealing with the more recent past in which humans are involved and the major agents in change on the Earth, and trying to understand how changes occur. By ignoring the humanities, you end up with oversimplistic paradigms of, for example, site use by Aboriginal people, which might be purely on ecological models. It's all about resource, it's all about energy, it's all about other things. And new archaeology is really reshaping the way that we understand human history by bringing in actual human perspectives rather than just relying on scientists. So it's a critical factor that we need to bring in where appropriate. I'll leave it to Susie and Steve to decide whether the humanities can shed too much light on their work. I think it definitely needs to be brought in the forward-casting understanding of things. I mean, how are these things relevant for the future? It's important to bring in the humanities, but we too often in the science world work in these kind of silos that are dislocated from other disciplines. So I think it's where it's appropriate, it's really important. And it definitely does occur. It's not just a flashy term.
I think sort of from my perspective with an interest in climate change, it's the interdisciplinary work is vitally important. But Susie and Steve, can you give examples of where you've learnt something really valuable or had a great experience, something that's been quite important from working with other disciplines?
I can take that first if you want, Steve. I think that actually, in what we do, one of the humanities that we work quite closely with, actually I have not done an enormous amount of work in this area, but a lot of my colleagues at the Natural History Museum do, is particularly the history of science. So working with historians, dinosaurs, again, have this incredible historical legacy that really was part of it changed the way, paleontology wasn't even a thing, really, until, the 1820s, the 1830s, and maybe later, really. So we have this kind of very well-documented historical legacy that's very important, particularly for us in the UK, because the founder of the Natural History Museum, Richard Owen, was the person who invented the word dinosauria. The first three dinosaurs the first three specimens that he recognised should be grouped together were from the UK. They're actually all from pretty much where I'm sitting right now in southern England in Sussex. So we have a really, really important historical legacy, and it's something that we take quite seriously. Next 2024, not next year, the year after, is actually the bicentenary of the naming of the first dinosaur, Megalosaurus. And so we're going to be doing quite a lot around that, and lots of celebrations around that, and we hope that we're going to be able to get some funding and work in some history of science sort of studies around that sort of thing. Obviously, I don't want to go on about representation of women in paleontology and things like that, but Mary Anning, I don't know whether you guys are familiar with Mary Anning, but again, one of the first people to really discover fossils in the UK, understand what they were, recognise what they were, was a woman and a working class, poor Victorian woman. So, really we have this very, very long legacy, and that's something that I think that we all deal with on a daily basis. Paleontology is one of these sciences where, we regularly consult papers that were written in 1870. And we have to go back to those original manuscripts. You write a paper and you think, well, maybe if you're doing computer science or something, it's going to be obsolete in 10 years. In paleo, that doesn't happen. People are still going to be referring to your papers 200 years later. So that sort of historical aspect is really critical to a lot of what we do.
Steve, do you have anything to add?
Our field is, like many scientific fields, very interdisciplinary. A lot of Susie's work that she publishes, it transcends discipline boundaries. I mean, Susie's trained as a geologist. She's done some of the most impressive work on biomechanics of how dinosaurs move. That just shows an example of how we're always shape-shifting when we're paleontologists. For me, some of the most fun collaborations have been in the past with statisticians, coming up with methods for testing things about evolution, how evolution works, how we can use fossil data to assess trends and diversity over time, those kind of things. We all CAT scan fossils all the time now. This is like the most common thing. A few decades ago, that was this big new technology, borrowed from medicine, using the X-rays to see inside of fossils. Now it's commonplace. You can barely even describe a dinosaur fossil without CAT scanning it. So we're always learning new things. We're always absorbing techniques from other fields. The best paleontologists are not, the people that are out just in the desert with their cowboy hats and their bullwhips digging up fossils. I mean, that's an important part of it, but that's only a small part of paleontology. And also, I think for people like Susie and me, we don't only do research. We do a lot of engagement. We do a lot of writing and work with broadcasting and television and so on. That's really important too. That's working with people from very different fields to communicate our research.
Well, I also imagine that, there's probably a little bit of humanities in your own work, given that being a New York Times bestseller, writing a popular science book, but also, I guess, the ultimate sort of transdisciplinary collaboration is working with Hollywood to bring dinosaurs to the big screen in a way. So, good on you for sharing your knowledge in a way that, might inspire the next generation of paleontologists. I see that big grin there. You don't really think of that as a scientific collaboration, hey?
No, well, you're absolutely right about when it comes to writing books and stuff. I mean, collaborating with really good editors, and I mean that's amazing. I mean, from an artistic standpoint, you learn a lot, and it really helps in your communication. The Jurassic World stuff. I mean, I kind of chuckle. I mean, I'm not hanging out in Hollywood or anything. I'm just answering emails and taking phone calls and trying to tell famous movie directors and great artists what they need to know about dinosaurs. But that is really fun because it is working with people who are just brilliant creative geniuses at the absolute top of their fields and giving a little insight, playing a small role in bringing these dinosaurs to the big screen where hundreds of millions of people are going to see these things. So if you think about a way to reach people, is there anything that reaches more people in the world, across the world, not just in the UK, not just in Australia, but everywhere, people of all ages, than a blockbuster film. So I feel very privileged to have that role and to just have, again, this small little voice that I have in the director's ear to hopefully help make these dinosaurs a little bit more accurate, a little bit more realistic, and to help introduce a new cast of dinosaurs. And you will see feathered dinosaurs finally in Jurassic World Dominion, which we're all very, very, very proud of.
Good to hear. And there you go, Anonymous. Hooray for the humanities and the artists and filmmakers. Now we have a question for Will, which he's placed to anyone. How much DNA is preserved in fossils millions of years old? And do we have the ability to map dinosaur or plant genomes to track genomic evolution? Who would like to take that? Would you like to start, Michael?
I deal with the recent past, so the DNA is quite common in sediments and things like that. But as you go back further in time, there's definitely degradation. I have to defer to the experts about millions of years old, though.
Mm-hmm. Genomic research for dinosaurs, is that a thing? Is there enough preserved?
I'll go first on that as well, and Steve can come in and say all the things that I haven't said.
Susie actually knows about it. Susie published some of the interesting work on finding, biomolecules and so on in dinosaurs. So I have no real informed opinion. I can give you the movie answer, but Susie can give you the science answer.
Well, we'll stick to Susie then.
all right, okay. So no is the answer. I mean, the short answer. The oldest DNA in the fossil record at this point is no more than 1 million years old. So dinosaurs died out 66 million years ago. So they're 66 times too old for DNA to be preserved at this point. However, I'm not going to say never, because things keep happening, technology keeps improving, discoveries keep being made. What we now know, and I think it's really becoming very widely accepted, is that actually there are soft tissues and the remains of soft tissues that can be preserved over geologic timescales. And there's this increasing body of evidence that's really been building for about 30 years. And when it was first discovered, people were suggesting there's a famous paleontologist in the States called Mary Schweitzer, and she was continuously finding these sort of breakdown products and remains of soft tissues and cellular structures. And she faced incredible backlash from the community, really. I read an article in which she said that a reviewer of one of her papers actually said, "It doesn't matter what evidence you show me, I will never believe you," which is incredible for a scientist to say something like that. But increasingly over the last 25 years, we've really seen this kind of paradigm change. And now there are actually people who have recovered what they consider to be breakdown products of DNA. So not whole DNA fragments, but breakdown products of DNA in dinosaur fossils, from dinosaur fossils, and indeed fossils older than the dinosaurs. So I'm not going to say never, but at the moment there isn't any dinosaur DNA. And of course in Jurassic Park, in the original Jurassic Park film, what they did was they recovered DNA from a mosquito, from blood from a mosquito. And actually, mosquitoes don't usually preserve, or fossils in amber don't usually preserve that sort of blood. They're much more kind of like husks. So you don't get those kind of soft tissues really preserved in that environment. But even if we did, in Jurassic Park, what they said was, well, we've got parts, fragments of the genome, and we're going to fill in the gaps in the DNA sequence with frog DNA. So there's a couple of problems with that. The first one is that you don't know where the gaps are unless you've got the whole genome to start off with. And the second one is, if you were going to find a terrestrial vertebrate whose DNA you would use to fill in those gaps, we are more closely related to dinosaurs than frogs. So it just wouldn't be frogs. You would totally use a bird. But anyway, that's beside the point. But I think at the moment, no, but I'm not going to say never.
I'm trying to think, what year it was that I saw Jurassic Park, and think, how much did we know about different species and their genomes then, that how glaringly obvious a error was that. Anyway, now we've got a really fascinating question from Anonymous. How can paleontology help guide us in the search for alien life? I'm thinking exobiology and astrobiology. What can these fields learn from paleontology? Any takers on that one?
I can give a very brief answer just by saying, we have some astrobiologists on the faculty here in Edinburgh who are good friends and colleagues of mine. And it's a field I know very little about, but they do take inspiration from paleontology. And, one of my friends here, a guy named Sean McMahon, is a leading young astrobiologist. One of the things he's always talking about is, and he's put this in papers and so on, is, how to find a fossil on Mars. How do you go, if there was a mission to Mars, or if there was a fragment of a piece of Mars that came to Earth, could you identify fossils on there? How would you do it? And that's taking, of course, inspiration from paleontology. It's taking information from paleontology, how do we identify fossils here on Earth, and applying that to other planets. I don't know anything about it. For me, I study things like T-Rexes, these big giant animals, little bacterial fossils. I'm lost, but it seems like an incredibly exciting discipline. Clearly, this is one of the areas where our science is going. And I can tell you just from the number of students that are interested in studying it, that take the astrobiology courses, it's a very, very buoyant field and a very fun one.
I guess, Susie, I might poke you and prompt you with this. One of the things that, and this is me as a generalist reading some articles about some work that was discovering about how fast different dinosaurs might run because of what they'd seen from the skeletons and the bone structure and because you look at herbivores, am I right in that the largest dinosaurs are herbivores? Is that right?
That's right, yeah.
And think about that, people, that you can get that big as the largest dinosaurs on a vegan diet. It's food for thought, isn't it? But does that give you the idea of, both your study of environments that these animals existed in, and were there surprises from what weight and pressure on bones is possible that would make you change your thinking about what environments, gravity, different forces to look for on other planets? Does it challenge your idea of what's possible?
Actually, that's an interesting point, because, when the biggest dinosaurs were first discovered, the sauropods, the long neck, long tailed dinosaurs, things like Diplodocus and Brontosaurus, all those dinosaurs that we will name on the 7, they, when people first discovered them, they just thought this is, these things, they must live in water. There is no way that these animals can possibly support their own weight. They're just far too big. And of course, now we know that that's not true at all. And actually, that they could support their own weight, and we can biomechanically model that they can. But also through investigations of their skeleton, we know actually, their skeletons are much lighter than an equivalent mammals might have been, because the vertebrae are all filled with air spaces and air sacs, which are actually extensions from the lungs. And this is something that we also see in birds, which also need to lighten their skeletons, of course, so that they can fly. And the dinosaurs, so, I think if we took a mammal and we scaled it up that big, it would be really, really, really heavy. But actually, you know, dinosaurs, that's not how the sauropods achieved being really big. They were able to lighten their skeleton in a variety of ways. And we do now know that maybe our preconceived ideas about what is possible based on our current time slice are wrong. And that actually, you know, when we go back and look at the past, we learn that you know, these preconceived ideas have actually, you know, they're not right, and there are examples of them being wrong. And maybe this is a lesson that we can take to looking for life on other planets, that actually, you know, we shouldn't go in there with a preconception of what life might look like, for example, or what, you know, what life is. You know, is it all going to be carbon-based? Is it, you know, is it going to be something else? So maybe going in, maybe that's a lesson we can learn, is that going in without preconceived ideas would be a good way to start.
A good lesson. Anonymous has another question. Anonymous asked quite a few questions. Good questioner. Are there any thoughts on how to decolonise paleontology and include First Nations voices across the world? How would this improve research and collaboration? Look, Michael, I think you're the first person to answer on this one.
Yeah, well, I guess we'd have to move into the more recent past. I don't think anyone could really argue that humans are running around with Triceratops. But I think we need to, and Susie touches on it really well, and I assume in her research with biases in science, I mean, the sheer fact of asking a question of how would bones, could that tell us about bone structures on other planets, is the assumption that there's bones on other planets. You know, we carry these preconceived ideas that set the questions we ask, you know, and then that guides the kind of analysis we do, which dictates the kind of answers we get. And that's essentially the decolonisation process, is trying to slice the cake in different ways and ask different questions. And I think that we can look to different ways of knowing to understand what were these large animals that did coexist with people, what were they doing, how were people interacting with them, rather than just going in. And a classic example in Australia is this idea that Aboriginal people arrived and wiped out the megafauna through overhunting because it had been recorded somewhere in North America with blitzkrieg sites and the death of the woolly mammoth and things like this. Whereas it's categorically not true, or there's just no evidence for it. But we're still fixed on this idea, which is this sort of preconceived idea of a singular way that people interact with the world around them. And we haven't taken the time to actually ask First Nations people, well, how did you interact with, or what knowledge is there in your traditions that shows interactions between large animals and people? And we sort of keep recycling these paradigms of, okay, well, they disappeared, therefore it must have been people because it happened here in North America or it happened here in Europe or something like this. So it's just about taking a step back and understanding what assumptions you're bringing into the question asking, and then you may end up with different directions. And I think Sue just pointed out a perfect example there about bone structure. You know, like we just carry this assumption that there were bones, they must have the same density, exactly the same, and you end up with these ridiculous notions that an animal can't walk, you know, because it's too heavy. So the fact that you can slice the cake a different way and ask different questions is really important, especially at that period of overlap between people and these large animals, and so we can understand how we can coexist with these things or not. And we still have megafauna in Australia today. There's still megafauna in Africa. People came from Africa and they've coexisted with megafauna for, you know, at least 1.5 million years. So there are different ways we can do it by asking different questions with different perspectives.
Do you think there needs to be more, well, I guess funding or support for traditional owner research First Peoples, in not just, you know, as individuals and as researchers, but supporting collaborations and getting some of that?
Yeah, I think
breaking down?
that would be great, but the first step is listening. There's not enough listening or even engaging. You know, it's usually sort of flying in with preconceived wants or notions or directions, and seeking support sometimes as a box tick or sometimes as logistical support, rather than actually sitting back and having a conversation and coming up with questions together, do you know? So I think the step back is actually just sitting down and listening and co-creating, rather than just sort of funding an existing model. You know? So I think the first step there is that kind of listening. And then, putting energy and resources into that co-creation is the next step along, for sure.
I know one of the things that me with my biases, but a thing that I'm really concerned about is the loss of Indigenous languages and what that might mean for the loss of knowledge, but that's me with my biased thinking. Is that something that concerns you from a scientific and a cultural point of view?
Oh, definitely. And I kind of don't often. I sort of sit in a place where science and culture meet, like regularly in my head. So, language conveys so much. I mean, there's languages in the north of Australia where there's, at least a dozen words for fire, for example, about the different nuances of fire. Whereas, there are simplistic notions that we have about fire in modern cities and societies today. So there's not only a loss of culture, but there's an incredible loss of information with that, And languages, and anyone who speaks another language will know that it actually starts shaping the way that you think and interact. And my partner and I, and actually my family, have just started learning our language, Wiradjuri. And I'll just give you an anecdote. The word to give birth, right, actually translates in Wiradjuri as to pierce through from another realm. So these are just, it's not just, fitting one to one. It's actually just thinking about the world in a completely different way, and a way that has developed in place over 50, 60, 70,000 years that has so much information encoded in it on how to live appropriately in a place. And I think that happens all over the world. And losing these languages is losing information. It's losing knowledge on how to actually operate. And I think the world is mostly European derived, and European people have been living in Europe and operating in Europe for millennia. So it's a very in place, localised knowledge set that's been sort of cast over the world. And many of the problems we face today, species loss, salinisation of soils, all these sorts of things, are because of the application of inappropriate paradigms. We just don't have that knowledge because we're ignoring the vast amount of knowledge that's encoded in local languages and local knowledge. It's not only just about preserving language for the sake of it, it's about tapping into that knowledge and actually adjusting the way that we view and live in the world so that we can live in this place rather than destroy this place, and then have to think about whether or not life can be supported on another planet because we've stuffed this one, and whether astrobiology can help us there. It's all fascinating stuff, but we don't want it to be that we have to go to that resort. I think, and a key way there is sitting down, listening to people, helping reconstruct language, helping revive language, and learning from it. So.
And going to you, Susie and Steve, is this something that is coming into the practice of paleontology, particularly field paleontology? Is this starting to change the way you and your institutions work?
Yeah, I think there is absolutely a big movement at the moment, and I think actually there's a paper or a news article in Nature this week on decolonisation in paleontology. It's become a very hot topic. How do we deal with our and make up for our particularly European colonial legacy, really, of going to places in the early part of the 20th century, latter part of the 19th century, taking the fossils and bringing them back. We have collections from across the globe. We have one in the Natural History Museum. We have one of the most geographically diverse collections, but that's because of our colonial past and our colonial history. So how do we go about that, making that good, making that right, making that better, and how do we address how we work today? And there is this big idea about parachute science, which is where we, as generally Europeans or people of European origin, go into developing world countries and particularly in the global south, and go in, take a fossil, bring it back, do our work, don't include local authors, don't include local knowledge. And there is a narrative that this is something that paleontology has suffered from, or is suffering from at the moment. And to be honest, I would argue that actually for many years we've not been doing that. And that those of us that work in vertebrate paleontology, the majority of us that do engage with local communities, we do engage with local authors, and we have been doing so. I'm really taken by what Michael has just said, because what I feel that's happened at the moment is that we are, to some extent, being preached at by each other, by a bunch of other Europeans telling us how we should behave. And actually, maybe what we need to do is to listen to people from the countries where the fossils are that we're working on, and find out what they want, what they would like. rather than saying, well, best practice is this or best practice is that, without maybe engaging with the people that we need to talk to, or without that isn't coming from the people that we need to talk to. And so I'm really, really taken by what Michael has just said about listening and about sort of the first steps being kind of a softly approach. I feel like it's a bit of a blunt instrument at the moment.
Yes. Well, we're almost out of time, so I'm going to now come to the last question from the audience, which is, Anonymous is getting another go, but it is a really good question, and I think I'd like all of you to answer this briefly. What does this mean for us now? What is a valuable lesson we can learn from deep history and enact now to help protect life on our planet? Who would like to go first? Steve, whenever you do that big wide-eyed and those eyebrows that say, don't ask me, it just makes me want to ask you.
I'll go ahead. First of all, just to echo, what's been said about representation in science. I mean, we're as scientists, we're trying to push the boundaries, we're trying to understand our world, we're trying to discover new things, and we have to be maximally accessible. It's just shame that anybody is cut out of being part of that process. So just to completely boost what's just been said. What does it all mean for fossils? I mean, I'm turning a lot of my attention to mammals now, and that's not just to plug the new book, but it kind of is. One of the things I've learned a lot about mammals in writing the new book, and one of the things that I had to kind of beef up on is modern day extinctions. What's happening now? There's a lot of talk about a sixth extinction. Is it a sixth extinction? By the way, we call it a sixth extinction because there's been 5 mass extinctions in Earth history in the geological record. And are we now in a sixth? Things are changing very fast, and there have been a lot of mammals that have gone extinct. There have been something like about 350 mammals that we know of that have gone extinct just since Homo sapiens, our species, started meandering around during the last ice age. And around 80 or so of those, it's always hard to get these numbers right, but around 80 or so of those have gone extinct in the last 500 years. And generally in the time that humans have started keeping records, when we've known what's out there and we've known what we've killed. And, in one sense, that's kind of scary. I mean, that's about 1.5% of all mammals. Okay, maybe that's a small number, but that's in just a tiny, tiny, tiny period of time. So that pace of extinction is really fast. And if this continues at this pace, by the end of this century, there might be over 500 mammals is the estimate that might go extinct. That would be about 10% of mammal diversity. Okay, these are a lot of numbers I'm giving, but the point is, this is happening really fast, and it's worrying. However, these numbers are not yet to the level of a mass extinction. Mass extinctions in the fossil record are times when 70, 80, 90% of species go extinct. We are not there yet. There is plenty of time for us to prevent us from getting to those numbers. So I think fossils give us a perspective. They tell us about extinctions in the past and how ecosystems have responded to catastrophic moments and great changes in the past. And I think combined with our own human history, things we know about our world today, we have the information. We know what we're doing. It's up to us to act on it. So it's not a doom and gloom scenario for me. We are still far from a sixth extinction, but it is our choice. It's our choice, and it really is a choice, because evolution has never produced a species like us that has such a large brain, such high intelligence, consciousness that's able to affect the world in such a way, but also see and understand how we are affecting it. So it is a choice. Evolution's also given us this great ability to work together socially. So I hope that over the next few decades, this very critical time, that we take the right lessons from the fossil record.
Susie.
Yeah, I mean, that was a great answer from Steve. I think, if we, on our warming Earth, on our changing planet, if we seek to want to understand, for example, how the ranges of large vertebrates are going to change, or how diseases and their vectors are going to spread, then, we can't do that just by looking at today's time slice. We can't, today is an instant in time. We can't get a perspective of change just from looking at today. So the only way that we can look at change and over time is to go back into the past and look at when things have changed in a similar sort of way. So that could be at the KPG mass extinction that wiped out the dinosaurs. It could be a smaller mass extinction. But what we can do is we can research those mass extinctions. We can look at the tempo of extinction. And Steve has done some great work around this himself, actually. We can look at the mode of extinction, and we can look at faunal recovery after the extinction. How long did ecosystems take to stabilise? How long, what were faunas like after those mass extinction events? And so actually, I think that studying paleontology has never been more important than it is today.
Thanks, Susie. And finally, Michael.
Yeah, I mean, these guys have hit the nail on the head. I think, the Earth operates at various rhythms. I've just spent the last week in the highlands of Tasmania walking, just over 100 k's actually, in search of understanding the long-term history of a tree that's about to go extinct. And this tree lives for 2,500 years. So whilst we are this incredibly intelligent, sentient, conscious agent, we have short lifespans, and we have a very short memory, and we've been doing serious ecology, observing the Earth for a short amount of time, 50 years, 100 years, maybe as a long-term ecological study. So what we do collectively, and other people in the paleo sciences, is provide that critical temporal perspective that shows those rhythms, that shows that there are cycles and patterns and processes that occur at different scales that affect different things. And if we are to move forward and do things appropriately, or mitigate the species loss so it doesn't turn into a mass extinction event. It's nice. I like the optimism there, Steve. I think you're right. It's not quite there yet, but we need to understand how these things operate. We can't just put Band-Aids on the problem. We need to actually get a grip of what's going on, bring in the various understandings, and then we can have an appropriate way to go forward. So I think that's what the fossil record does at all its scales, from the recent right through to the deep past. I think it's all critical information on how the world works and the rhythms that it operates and how we can live in it.
Yep, and from the macro, that charismatic megafauna, to the micro, the little fossils.
And down to the micro, the DNA,
Yes.
it's all critical, if we're going to move forward, I think.
Now, before we get one final pearl of wisdom for each of our panellists, I just wanted to let you know a couple of little things. One is that this event is being recorded and it will be emailed to you, the audience, probably tomorrow. With that email, you'll also get sent a link to a survey, and also as you leave, for the people in the room here today, the staff will be handing out a QR code. And that's an audience survey just to find out from you what you enjoyed about tonight, any suggestions for improvement, because the museum naturally does want to make these events as rich and exciting experiences as they possibly can. So please do provide that feedback. So really, that all I need to do now is hand back to the panellists to find out, a pearl of wisdom from each of them. I'll start with you, Susie. What's a final parting thought you'd like to leave with us?
Oh wow, throw me in the deep end. I think that my parting thought is going to be around lots of things that we've covered already, about how that we can, how important paleontology, the deep past, is. We've just talked about for environments, but I actually think about it for communication and for understanding science and for engaging people with the natural world and inspiring people to engage with their environments and on a small scale, on a large scale. I think we can use dinosaurs as this vehicle, which I've already said, to really get through to people really important messages about their environment and help everyone from really small children to adults start to understand some of those messages in an engaging and interesting way.
Thank you, Susie. Steve?
Well, I would say it's for those of us that care about the Earth and environments and climate change, and for those of us that look at the news and see the way fires are, raging across parts of Australia, and of course other times a year that rage across the U.S. and we have big hurricanes and big floods and storms are getting more severe and there's bigger droughts, and we know why this is happening. And for those of us that know this and care about this, it can be very demoralizing, I think, because politics and social media and talking about these things with our families sometimes, it can just be, let's face it, can just be cesspools, and it can be very hard to very easy to just give up and say, we're all doomed. We're not there yet. We still have time to make some real changes. The more we learn from the fossil record, the more we learn that what's happening today, changes are happening very, very, very fast, but there is still time. There is still time. And small actions, even small individual actions, can be important. We're such a big species. There's 7 or 8 billion of us, but small little things that we can do to remain optimistic but make real changes. Don't give up. Don't give up. There's still a long way to go until we get a mass extinction, but we do have to do something about it.
Thank you, Steve. Michael.
Yeah, I think for me it's placing ourselves in the right context. We're all in this rat race. It's next meeting, next Zoom, next this, next that. Stepping out and just lengthening our time perspective out a little bit and understanding that we're in this continuous thing, in a landscape that's evolving and changing and that has been a certain way, and focus on that rather than just the immediate. And it sort of touches on what Susie's saying, which our people will call connection to country. Connect. Take the time to look around. Take the time to, I do it every year. I say, the wattles are out. It's nearly the end of winter. These kinds of things. Understand that we're in this continuous time. It's not just all now, everything. And that sort of feeds that consumptive attitude and this sort of use and abuse, take a step out and look at where we are and the rhythms of where we are. And I think the fossil record can really show us that. But it's up to us to sort of take the lessons on.
True. It's feeling those natural rhythms, isn't it? I have 3 final thoughts. One is to, we've been thinking about the deep past and do think about the deep past, but also have a focus for the future. Shameless plug for Melbourne Museum. Go to museumsvictoria.com.au/future-forums if you'd like to find out about more events like this one. So do keep thinking about the future. Second one, stay hopeful. We've heard from Steve that there are reasons to be hopeful. And finally, stay curious. This is what museums are all about. This is why people visit them. This is why people are interested in the natural world. It's why children look up at the moon and think that it's amazing. So thank you everyone for attending tonight. Thank you for those who joined us online. Finally, please join me in thanking our amazing panel, Michael, Susie and Steve. And thank you all for your questions. Have a good evening and thanks again for your questions. Good night.